Hey guys, so today we are wrapping up our systems of equations units with systems of linear inequalities. So we're taking our last lesson from unit 4, which was graphing linear inequalities, and using that with what we've learned so far in our systems unit. And today we're going to be graphing systems of linear inequalities. So let's go ahead and dive in with some examples. So in today's lesson, hopefully you have already written down the notes and you've completed those. We're going to be using those steps to help us with our examples today. So in this first example, example 5, first thing that we need to do is take this first line and graph it. So we take our y-intercept and plot it directly on our y-axis. Then we do rise over run with the slope. So since my slope is a negative 5/2, that means I can go down 5, 1, 2, 3, 4, 5. I'm running off the graph, right 2, and make a dot. I can also go the other direction, up 1, 2, 3, 4, 5, left 2. I notice that since it has a solid line underneath the inequality symbol, that means that I'm going to have a solid line as well. So once again, do your best to make that as straight a line as possible. I know mine's a little off. Now then, if we cover up this x term, I want to shade the region where the y's are less than or equal to -2. Remember, we're covering up that x term. What that's doing is it's letting us go directly to our y-axis, so we don't have to worry about above the line, below the line, anything like that. We can just focus on our y-axis. So the y's less than -2. So right down here is -2. All the y's less than that are going to be down here. So that means this underneath side of the line will be shaded. So now we're done with the top line. So now let's do the same steps to that bottom line. So we start with our y-intercept of +2. From there we do rise over run with our slope. Since it's a negative, I know that I'm going down 1, right 2, down 1, right 2, down 1, right 2. I could also go the other direction, up 1, left 2, there it is, there's where they cross. Up 1, left 2, up 1, left 2. Since this has no equal to line, it's going to be a dashed line. So I can come right here, making my dashed lines. And then whenever we cover up this x term, we want the y's less than +2. So we're going right back to this y-axis. The y's less than 2. Well, that's all of these things down here. So everything under this line is shaded. So now we get to the systems part. Notice how this section right here, I'm going to pick a different color, maybe this blue. This section right here is shaded twice. Do you see that? That right there is going to be the solution to the system of linear inequalities. So the stuff that was shaded in just black was the solution set to this top line. The stuff that was shaded in red is the solution to just this line, but to be the solution to the system of linear inequalities, it had to be shaded twice. So the part that overlapped was that solution, okay? Let's look at another one. I'll try to plan my colors better. We'll use blue and red and then maybe shade the overlap in black. So on this next example, once again, we start off with that y-intercept. So we go up 3, 1, 2, 3, make a dot. From there, we do rise over run with our slope. So we're gonna rise 2, run 1, 2, 3. We're gonna go the other way. Down 2, left 1, 2, 3. Down 2, left 1, 2, 3. Since it has a solid line, I know that I'm going to have a solid line as well. So we make our solid line right through there. If we were to cover up that x term, we want the y's greater than 3. So on my y-axis, the y's greater than 3 are going to be like 4, 5, 6, 27. That would be way up here. So that means everything on this side of that line is shaded. So now whenever we go to our second line, we plot the y-intercept directly on our y-axis down at -3, make a dot. From there we do rise over run with our slope. So it's going to be down 4, right 3. So down 1, 2, 3, 4, going off the graph, over 1, 2, 3. We could also go up 1, 2, 3, 4, left 1, 2, 3. There's where they cross. Up 1, 2, 3, 4, over 1, 2, 3. Since they do not have that equal to line, it's just greater than, it's going to be a dashed line for us. So we start making our dash. If we cover up that x term, that lets us deal with that y-axis only. I want the y's greater than -3. So here's where -3 is. I want the y's greater than that. So that's like these points up here. So that tells me that everything on this side of that line is shaded, like my shading job. So now we look for the spot that is shaded twice, or that part that overlaps. It's going to be this region right here. So notice how I'm still shading the solution to that top line, still shading the solution to the bottom line, but the only part that is the true answer is this overlap region. So that's why I'm shading it much darker. Okay? Give me just a second. I'm going to scroll down so we can do a couple more examples. So in these examples, we have a couple of special cases, I would call it. And not necessarily that they're crazy lines, but we've got some that are a little bit interesting to graph. So notice how in this top equation, it's not in slope-intercept form. Don't panic if you get a line that's not in slope-intercept form. It's very easy to get it that way. What we need to do is we just need to make it that way. So if we take 4x plus y is less than 2, we need to get the y by itself for it to be in slope-intercept form. So we could subtract 4x from both sides, and we'd be left with y is less than -4x plus 2. Now it's ready to graph. It's in slope-intercept form. We take that y-intercept and plot it directly on the y-axis. My slope isn't a fraction, so I turn it into 1 by placing it over 1. So now we can go down 1, 2, 3, 4, over 1, down 1, 2, 3, 4, over 1. We could also go up 1, 2, 3, 4, over 1. Since it does not have the equal to sign, that means it's going to be a dashed line. And then whenever we cover up that x term, that gets us to look at just the y-axis. So we want the y's less than 2. Y's less than 2 would be like 1, -2, -5. So that tells me that everything on this side of the line is going to be shaded. So now let's graph the second line. Y greater than -2. I notice here that this is my y-intercept because it's the number that's by itself. So I go down to 2, make a dot. However, this line doesn't have a slope. Its slope is 0. So that tells me it's going to be a horizontal line right there at 2. Once again, it does not have that equal to sign, so it's going to be a dashed line. Now I want the y's greater than that. Well, greater than -2 would be anything up here. So that's this region up here. Notice the part that was shaded twice, or the part that overlaps, is this section right here. Okay, last one. I'm going to have to erase this so we can have room. Notice how on example 8 that both lines need to be put in y-intercept form or slope-intercept form. So I'm going to erase this so we have more room. And I'll work them in different colors again so you can see a little easier. If we have 3x plus 2y is greater than or equal to -2. My goal to get it in slope-intercept form, I need that y to be by itself. So we're going to subtract 3x from both sides. That leaves us with 2y greater than or equal to negative 3x minus 2. Divide both sides by 2, and we get y greater than or equal to negative 3 over 2x minus 1. Now this line's ready to graph. So we can plot our y-intercept directly on our y-axis there at negative 1. Since our slope is negative, we're going to go down 1, 2, 3 over 2. We can also go up 1, 2, 3, left 2, up 1, 2, 3, left 2. It does have that equal to sign, so that tells me that we're going to have a solid line. If we were to cover up that x term, I want the y's greater than negative 1. Y's greater than negative 1 would be like 2, 4, 6, stuff up there. So everything on this side of that line would be shaded. For our other line, we need x plus 2y greater than or equal to 2. Get the y by itself, so we're going to subtract x from both sides. 2y less than or equal to negative x plus 2. Divide everything by 2 to get the y by itself. So we're left with y less than or equal to negative 1 over 2x plus 1. I know we're getting really close to the edge here. So we go up 1 on our y-axis, make a dot. Then we go down 1, right 2. Down 1, right 2. We could also go up 1, left 2. There's where they cross. Up 1, left 2. Up 1, left 2. So somewhere right around in there. It does have that equal to line, so we get to draw a solid line here. If we were to cover up that x term, we want the y's less than 1. Y's less than 1 would be everything down here below that line. So the part that's shaded is this middle portion right there in between those lines. Whenever you're graphing a system of linear inequalities, take it one line at a time. Don't try to graph both lines and then shade both lines. Fully complete that one line first. That way you don't get confused with where one line starts and the other one stops and all that kind of stuff, okay? If you have any questions on this lesson today, feel free to give me a call or shoot me a text and I'd be happy to help you. Good luck.